Welcome back to our final installment and looking at data analysis in week 3. And in this session together, we're going to pick up our discussion about the t-test in a bit more detail than we had an opportunity to cover in our previous time together. As you know, we're focusing our attention at present on analyzing data. So we're beginning to select statistics to understand the relationship between the variables that we've chosen for our analytic model. So we've talked about this quite extensively, and I just want to reiterate how absolutely important it is that your inferential statistics follow your descriptive statistics, that you do your histograms, your box plots, and look at your means and your medians before you ever pick a statistic. Because hopefully, as you see in this case example today, if we don't do this descriptive work first, we're very unlikely to pick the correct inferential statistic. And then we get an answer to the statistic, but it doesn't answer our primary question. So let's talk for a moment about how to prepare some variables within SPSS. We've been looking at how the state in which a hospital is can have an effect on some of the outcome variables that we've looked at. So what I'd like to do now is take a look at the state variable within SPSS and talk about how we can modify it for our analysis purposes. So as you have a chance, please open up the data set we've been working with, and let's go to the data view and look at our state variable. Once we click on the state and move to the variable view, here in line 4, we see that state is a string variable, which in statistical language means it's text. It's a number that we can't actually analyze. So what I'd like to do is demonstrate how we can take the string variable of state and convert it into a number that we can use for statistical purposes. So if you go to your top menu and you go to the transform menu at the top, select automatic recode. And once we've gone to automatic recode, let's scroll down and select state, put it into this variable to new variable box, and let's give this new variable name. Let's call it state number. And we'll treat any blank numbers in the database as though they're missing for user error. And click Add New Name, and OK. Now, what you'll see in your SPSS output is here a summary of the old state, variable state, for example, AK for Arkansas, has been converted into the new value number 1, and it's labeled AK, so for Arkansas. Excuse me. So what we can do now is we can use this number assigned to the state as a means for analyzing information about that state. So let's see how that works. So we'll begin by looking at our research hypothesis that the number of heart failure readmissions, or the excess readmission ratios, are not different between states. So we've used our Emory roadmap to guide our analysis so far. So we're going to keep coming back to that roadmap. And so let's flip to that so that we understand where to begin in looking at this excess heart failure readmission ratio. And then once we understand that number, we can create an analytic plan together. So we've said we're always beginning by exploring every variable that we plan to use and analyze. And one of the first steps is to look at the distribution of the data. And we can do that by looking at the range, the medians, and the means, or we can quickly do it using histograms. So let's create a histogram looking at this outcome variable for the excess heart failure readmission ratio. So again, back in SPSS, we're going to go to Graphs, Chart Builder, and we are going to begin by looking at a histogram to see how the data for heart failure readmission, excess readmissions, spread based on state. So here we are in a chart builder. We're going to go to the gallery, select our histogram, and then we're going to use as a predictor variable the heart failure readmission excess ratio. And so let's see what this histogram looks like. Let's go ahead and graph it. And you can see here the data appear to be essentially normally distributed when we look at the excess readmission ratio for all states. Now let's compare state by state and see if that holds true at the state level. So we'll go back to SPSS, and under the Graphs menu, go to Compare Subgroups. What I'd like us to do now is use that new variable we created called state number and place that in the subgroups defined by box. And we're going to use the heart failure excess readmission ratio as our outcome variable. So we'll scroll through and select that one. And let's graph those data. Now what you'll have are plots for each and every state now given to you individually. Instead of all the states presented as one graph, you'll have them uniquely presented here. So if you see, we begin with the state AK, and x-axis is the heart failure readmission excess ratio. And so you can see the black line would be a normally distributed curve, and the bluish purple color in the center is that state's actual distribution. So I want you to scroll through here and see if you can find two states that look essentially normally distributed. So you found here that Illinois very closely follows the normal distribution. You have a little bit of a peak here to the right-hand side of the curve and a little bit of absence in the left tail, but a very close to normal distribution. Let's find our second one. Here we see that Louisiana also very closely follows the normal distribution. A little bit of stronger emphasis on the right-hand side of the curve and a little bit of gap in observations on the left-hand side of the curve, but very close to normal. So let's go ahead and explore the variable. We'll go up to Analyze, the Analyze menu, Descriptive Statistics, and Explore. Once we're in there, we're going to select as our dependent variable the same one we've been using, the heart failure excess readmission ratio. You can click on it, select as a dependent, and then now we're going to factor by the state number. So let's choose only statistics so we don't have extra graphs, and say OK. So now what you'll find are the descriptive statistics broken out by state for the heart failure readmission excess ratio. So if you scroll through here, I want you to find the means and the medians for our two states of interest, and you'll see that the means and medians are very, very close, which support our conclusion that the variables are essentially normally distributed based on looking at the graphs. So here's Illinois by way of example. You can see that the mean excess heart failure readmission ratio is 1.0187, and the median is 1.0185. So these are essentially identical measures of central tendency. Go ahead and scroll down to Louisiana and see what you find there. Again, here in Louisiana, our mean of 1.02, very close to the median of 1.02. So all of these factors suggest that our data are normally distributed. So let's look at how we could compare the excess readmission ratio for heart failure for Louisiana and Illinois. A t-test assumes that the distribution of the data are normal, and we saw that for Illinois and Louisiana that was essentially true. The outcome variable has a level of measurement that's interval or ratio, and that's also true for our excess readmission ratio. We're comparing two groups, and the observations are essentially independent. So the null hypothesis is there's no difference between the mean of the two groups. So in this case, there's no difference in the mean heart failure readmission, excess readmission ratio for Illinois compared to Louisiana. So let's formally test this statistically. So we'll come back to SPSS, and in our Analyze menu, we'll go to Compare Means, and for our means, we're going to do independent sample t-tests. So we'll pick the same variables, except this time when we choose grouping based on state, we're going to define which two states we're looking at. Now, if you go to your output earlier, you'll see that Illinois is listed as state number 17, and Louisiana as state number 21. It's in the output from above. So we'll say yes, let's select those two groups and run this test. So when we run the test, we see here we have Illinois and Louisiana listed, the mean of the variable listed here, and now we have the t-test. The first box assumes equal variance, and the second box does not assume equal variance. So if we go back to our descriptive statistics for Illinois and Louisiana, we want to see how the standard deviations of these two states compare. So the standard deviation for Illinois is 0.076, and if we scroll down, we see that the standard deviation for Louisiana is 0.079. So these are very, very close in their orders of magnitude. So when we look at our t-test, we want to use the t-test that assumes equal variance because we saw that the standard deviations are essentially the same for these two values. So we can see that our p-value of the t-test that tests the difference between the excess heart failure readmission ratio in Illinois compared to Louisiana is 0.509. So let's go back to our statistical model and see what this means. You can see that the null hypothesis of the t-test is that the mean of group 1 equals the mean of group 2. And so in our situation, we've used the t-test to see if the mean of Illinois and the mean of Louisiana are equivalent, statistically speaking. And with a p-value of 0.5, we're much, much, much higher than our threshold of 0.05. So with that, we fail to reject the null hypothesis that Illinois and Louisiana have statistically equivalent proportions of excess heart failure readmissions. So if we look at this graphically, Illinois' at point estimate was 1.0187 with a range between 0.86 and 1.17. Similarly, Louisiana ranged between 0.86 and 1.17 with the point estimate of 0.102. So if you overlay these curves, you see that they essentially overlap. The 95% confidence interval for these 2 point estimates overlap. So we cannot say that there's a difference in the readmission ratios of heart failure between these two states. So I hope collectively we're seeing that statistics have an incredible power to summarize vast amounts of data. We could have scrolled through each and every point estimate for every hospital in Illinois and Louisiana and tried to make sense of them, but statistically we've been able to compare them with one p-value and very powerfully conclude that we can't tell a difference between the ratios for these two states. So we've seen a t-test at work, and in future sessions we'll talk about non-parametric tests like the Wilcoxon rank sum. Have a wonderful analytic week.